Today we're going to be talking about function inverses. This is section 7.2 in the Algebra 2 book. An inverse of a function, by definition, is its reflection over the line y equals x. The line y equals x is a line that goes through the origin leaning to the right, and if you look at the parabola sitting on the y-axis and the sideways parabola sitting on the x-axis, they would fold on top of each other. If we folded the picture along this dotted diagonal line, they would be inverses of each other. To find an inverse by hand, you switch the x and the y, and if it's an equation, then you resolve the equation for y. Looking at number 1, we have coordinates 1, 5, 4, 2, negative 3, 6. To find the inverse, all I have to do is switch those coordinates around. X becomes y, y becomes x. So the inverse would be 5, 1, 2, 4, 6, negative 3. Now the rest of them are equations. They get a little bit more complicated. When you do number 2, we start with y equals 2x minus 5. So to switch the x and the y, it would look like x equals 2y minus 5. Now we resolve this equation for y. Begin by adding 5 to the left side, and then divide by 2. So the equation inverse would be x plus 5 over 2 equals y. This is known as the inverse of our original equation. It would be its reflection over the line y equals x. If we folded the original line and this one over that dotted diagonal line, then you would see they would fold on top of each other. Try number 3 and 4. On number 3, we're going to switch the x and the y. So our equation will look like x equals parentheses y minus 3 squared. And now we're going to solve for y. Begin by square rooting to get rid of the squared, and then adding 3. So square root of x plus 3. The square root goes around just the x. The plus 3 is hanging on the end. And this is the equation for our inverse of our original. If you graph this equation and the original, they would be reflections over the line y equals x. On number 4, switch the place of the x and the y. So x equals y squared plus 1. We're going to subtract 1. And then square root. The square root goes over the whole thing x minus 1. Not just the x, over the whole thing x minus 1. And this is the inverse of our original equation. Are these inverses? Okay, we're going to begin by taking the first equation, the f equation, and we're going to say, instead of saying f of x equals, we're going to say y equals. So y equals negative 4x plus 8. This is the f equation, but we're just saying y equals. Now, I want you to find the inverse of this equation. So switch the x and the y. So it'll say x equals negative 4y plus 8. Now we're going to solve for y by subtracting 8. And then dividing by negative 4. This is the answer that we got for the inverse of f. However, this equation that we get is different than g. It's not the same equation as g. Therefore, f and g are not inverses of each other. Since the equation we got for the inverse is not the same as g of x, f and g are not inverses of each other. The equation we got for the inverse would have to match g in order for f and g to be inverses of each other.